Alright, so for this video, we're going to talk about graphing radical functions, so graphing the square root and the cube root functions. So a radical function is of the form f of x equals a to the I index of the root, b times x minus h plus k, and all the descriptions of all the different variables are there. I is the index of the radical. Again, if it's not written, it's the square root function. We know that. And these are just the regular transformations that we've been talking about when we've been talking about graphs and looking at functions. So A is the vertical stretch or compression, B is the horizontal stretch or compression, H is the horizontal shift from the parent function, and K is the vertical shift from the parent function. It's also right there. Oops. So looking at the parent square root function, that is just f of x equals the square root of x. So again, no transformations happening to it. So when you have the square root functions, this is the graph of the square root function, it does have an endpoint. So the parent square root function has an endpoint of 0, 0. And again, because it's like if I plug in 0 for x, the square root of 0 is just 0. Okay? And we can always find that endpoint by our HK, which we're going to talk about when we go to graph and when we read the graphs. So when you think about the x values that you want to plug in to kind of find the points on the graph, you want to think of the perfect squares. So remember the first few perfect squares are 1, 4, 9, 16, 25. Okay. So if I let x equal 1 and I plug that in, I know the square root of 1 is 1. If I go to my next one, the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. So that's how you get the points that are on the graph of the square root function. And we have a couple of them, again, shown on that graph. The domain of the parent square root function is 0, including it up to infinity. The range is also 0 to infinity, and I have an endpoint of 0, 0. So the endpoint is going to help kind of dictate the domain and range of a square root function. Cube root function, so if we take a look, the first piece of it that I'm highlighting right here is actually just the square root function that we just talked about. It's the graph of the square root function. But remember, with cube roots, we can take negative values of cube roots. So that is what this other half is also kind of looking like, is it's now the negative value of all of the perfect cubes and or all the values that are negative, all x's that are negative. So the domain for this is negative infinity to infinity. I can plug in anything I want, as well as the range. The vertex is, though, the kind of turning point. And when I say turning point, it's where we kind of see this directional kind of shift in the middle. So again, if we are now thinking about the perfect cubes, I'm thinking the perfect cubes are plus or minus 1, plus or minus 8, plus or minus 27, etc. So the main 5 points, I have my vertex of 0, 0 on my parent function. And then if I start from the vertex and work my way out, I get negative 1. The cube root of negative 1 is negative 1. The cube root of positive 1 is positive 1. And then I have the cube root of negative 8 is negative 2. And the cube root of positive 8 is positive 2. So when you're, again, trying to pick the x values to find the coordinates to plot your points, you want to think of values that are going to get you those perfect cubes. So that way when you take the cube root, you get whole numbers. All right, so we're going to start by just focusing on the square root function. So again, remember the general form is f of x is equal to a times the square root of x minus h plus k. So to graph a square root function, you're going to start by finding the endpoint of the function, which is the hk, evaluating the function and plotting those points and then drawing the graph. And we're going to answer all the questions about it. So my first function, I have the square root of x minus 1 plus 2. So right off the top, we have our h, we have our k. So that is going to be my endpoint, and my graph is going to be the point 1, 2. So I can go ahead and plot that, x1, y2. That's going to be my starting point. So now again, you want to think about the perfect squares and what we can get our x's to be in order to get the perfect squares inside of my radical. So I've identified my endpoint. So the next one would be if I want a perfect square value of 1. So if I let x minus 1 equal 1 and I solve for x, that gets me a value of 2. And when I plug 2 into my function, the square root of 2 minus 1, the square root of 1 is 1. 1 plus 2 is 3. And I can keep going. X minus 1 is 4 because I want this to be able to take the square root and get a whole number. So x minus 1 is equal to 4. So if I add 1, that gets me 5. The square root of 5 minus 1, the square root of 4 is 2. 2 plus 2 is 4. So that's going to be another point. If I let x minus 1 be 9, that gets me an x value of 10. The square root of 9 is 3, plus 2 is 5. And then to have this be 16, x minus 1 is 16. So adding 1 gets me 17. And then the square root of 16 is 4, plus 2 is 6. So those are the first 5 points that are going to be on this graph. So I can go ahead and plot what I can. So I have 1, 2, the endpoint already plotted. So I'm going to go ahead and plot 2, 3. And then I'm going to plot 5, 4. And then plot 10, 5. Going to be over here. And then 17, 6 is going to be off of the graph. But there is the rough sketch of that square root function. So now we can go ahead and do all of these questions. So the domain. So if I look at my x, the lowest x value that I can get is 1. So this is going to be from -1 up to positive infinity. And then if I look at my range, looking at my y-axis, the lowest y that I'm going to get is 2. And then it's going up. It's not going down. So that's going to be from 2 up to positive infinity, including 2. Okay, so there's my domain and my range. Intercepts. So this graph is not ever going to cross the x-axis or the y-axis, taking a look at how we graphed it. So there are no intercepts. If we think about it algebraically, so for my x-intercept, if I were to set this equal to 0, I'm just going to show you the math real quick, again, to check. So if I wanted to check in x-intercepts, doing x minus 1 plus 2 equals 0, that leaves me the square root of x minus 1 is equal to -2. And we know that we can't get the square root of a negative number, so that tells me I have no x-intercept. And when I do my y-intercept, that's when I know I plug in 0. That gives me the square root of 0 minus 1 plus 2. The square root of -1 automatically doesn't work because that's not possible in the real number system. So that's how algebraically I know that I don't have any intercepts. Next question is this graph increasing or decreasing? So if we take a look, it is going up. It's always going to be going up. So this graph is increasing. And then the last step is transformations from my parent functions. So if I take a look, there's 2 transformations from my parent function. The -1 inside of my function tells me that I have a shift right 1 unit. And then the +2 on the outside tells me that I have a shift up 2 units. So those are those 2 transformations that are happening from the parent square root function. All right, we'll go ahead on to the next one. So f of x equals -2 times the square root of x minus 1. So I have, again, my h and my k. There is no transformation happening inside of the square root. So that means my h value is 0. And I know that my k value, based off how it's written, is -1. So I have an endpoint of 0, -1 for this graph. So I'm going to go ahead and plot 0, -1. And I know that that's going to be my starting. So there is no shift left or right. So we can just finish this up with the perfect squares. So that would be 1, 4, 9, and 16. So I have, evaluating this, -2 times 1 is -2. -2 minus 1 is -3. -2 times the square root of 4, which is 2. -2 times 2 is -4. Minus 1 is -5. -2 times the square root of 9, which is 3. So that gets me -6 minus 1 is -7. And then -2 times the square root of 16, which is 4. So -2 times 4 is -8. -8 minus 1 is -9. So there are, again, the first 5 points. So I can plot those. 0, -1, 1, -3, 4, -5, 9, -7, and then the 16, -9 is going to be off the graph. Okay, so there's the graph of my square root function. So now answering all these questions, the domain, so looking at my x-axis, it's going to be starting at 0 and going to positive infinity. So that's going to be 0 up to positive infinity, and 0 is included. The range, since this graph is going down, so we can answer that one now. This graph is decreasing, not increasing. So I have the range. So the range, looking at my y, is going to be -1, and then that's going to go down to negative infinity. Let's close off. The intercepts. So this graph is never going to hit the x-axis, as we can see, but I do have a y-intercept here. So the y-intercept is going to be our endpoint, which is 0, -1. And the transformations from the parent function, so I have 3. So the first one is the negative out front. That tells me that I have a reflection. So I reflected over my x-axis. I have the 2 out front, so I know that that is a vertical stretch. So I stretched by a factor of 2. And then I have the -1 out back, so that is going to be a shift down 1 unit from the parent function. Okay. So that, again, that's how you graph a square root function and then work with all the different attributes and answer the different questions using that information. So the cube roots, you can skip these for now. We're going to come back to these when once I'm back at the end of the week. But I do want to go to the back. So we're able to do the first 3 questions on this back page. So writing now, so given the graph, we want to write the function. So remember, general function f of x equals a times the square root of x minus h plus k. So we need to find our a, we need to find our h, we need to find our k. So when I look at example A, I know my endpoint, taking a look, is 2, 5. And I know that the endpoint of a square root graph is my hk. So I just have those 2 values. Now to find my a, what you want to do is from the endpoint, go over 1 value. So I want to go to my right, 1 value, and then I want to count how much I go up or I go down from that point. So from my endpoint, and I go over 1, I go up 1. So since I go up 1, that tells me that I have an a value of positive 1. If I were to have gone down 1, then that would have been -1. Okay? And now we can just go ahead and plug all this in. So I have my function f of x is equal to a, which is 1, so there's an unwritten 1 there, times the square root of x minus h, so x minus 2, plus my k value of 5. And that is the function of that graph. If I look at b, I get my endpoint. My endpoint is 2 positive 3. So again, that tells me my h and my k. To find my a value, I'm taking a look at my endpoint. I'm going over 1. And I'm seeing now to get to that next point, I am dropping 1. So I have an a value of -1 now. So plugging that into my general form, I get that the square root function here is -1. So negative times the square root of x minus my h of 2 plus my k, which is 3. And let's go ahead to C. So starting again, I want to mark my endpoint. So my endpoint here is -1, 0. And so that's, I know my HK. And then my A value. So I'm starting at my endpoint. I go over 1, and I have to go up 1, 2, 3. So it tells me that I have an A value of 3. So plugging that in, my square root function is f of x equals 3 times the square root of x minus -1 is +1, and then there's an unwritten +0 at the end to account for that k.